സ്റ്റാർ എടുക്കുമ്പോഴത്തേക്ക് ഇത് കുറച്ച് നടുക്കോട്ട് വെച്ചു. എന്നിട്ട് ആ കണ്ടത്തിലേക്ക് കുറച്ച് വാല്യൂ ഞാൻ ഗോലേക്ക് കൊടുത്ത് അൺലിസ്റ്റഡിൽ ആരെ കാണാനാണ്? സ്ട്രീം ഒക്കെ അല്ലേ? സ്ട്രീം ഒക്കെ കുറച്ച് നേരെ മാമിനെ എനിക്ക് അങ്ങോട്ട് കുറച്ചുകൂടെ മാറ്റി കുറച്ചുകൂടെ ഇതാണെന്താ താഴെ അത് ഇവിടെ കാണാൻ പറ്റും. ഇവിടെ അപ്പോൾ പോഡിയം വേണ്ടെന്നാണോ പറയുന്നത്? എടാ കുറച്ചും കൂടെ നീ ബാക്ക് ഇവിടെ നിന്ന് സാറിനെ കൂടെ ഇങ്ങോട്ട് ആക്കി. ഇത് കുറച്ച് നേരെ ഒരു സെക്കൻഡ് ഒന്ന് വെയിറ്റ് ചെയ്യണം. ഇല്ല അതാ നമുക്കൊരു പണി ചെയ്യാം. അല്ല സിം അങ്ങ് ഓഫ് ചെയ്തിടാം. സിം ഡിസേബിൾ ചെയ്യും. വാട്സാപ്പിലൊക്കെ കയറി വിളിക്കുന്നു ഒരുക്കന്മാർ.
വാട്സാപ്പ് ഡാറ്റ ബാക്ക്ഗ്രൗണ്ട് ഡാറ്റ ഓഫ് ചെയ്യും. ഡാറ്റ യൂസേജ് നോക്കണേ.
നീ ആ ടേബിൾ കുറച്ചിട്ട് ഇപ്പോഴോട്ട് വെച്ച് സ്ട്രെയിറ്റ് ആക്കി അവിടുന്ന് ചാർജ് പോയിരിക്കണേ. ഇത് നോക്കിയല്ലോ അങ്ങോട്ട് മാമിൻ്റെ ഇത് നോക്കിയല്ലേ കുറച്ച് അങ്ങോട്ട്
ഏതാ യൂട്യൂബിലാണോ?
യൂട്യൂബിലായോ?
ഇതുവരെ
കൊള്ളാം ഇപ്പോൾ ഇല്ലേ? അത് വരും സ്ട്രീം ലേറ്റൻസി ഉണ്ട്.
1 മിനിറ്റ്
അൾട്രാ ലോ ലേറ്റൻസിയാണ് കൊടുത്തിരിക്കുന്നത്.
ഇത്ര പേര് സാറേ സ്ക്രീനിൽ വരുമ്പോൾ
ഇതിൽ ബാക്ക്ഗ്രൗണ്ട് മെമൻറ്റോ എവിടെ ഇരിക്കുന്നു? രാജസ്ഥാനുള്ള
ആ ലൈവിൻ്റെ കണ്ടന്റ് ലിങ്ക് ഇല്ലേ, അത് വെച്ചിട്ടൊരു കണ്ടന്റ് ഉണ്ടാക്കി വിൻഡോസിൻ്റെ അടുത്ത് ചുമ്മാ ഒരു ബ്രീഫ് കണ്ടന്റ് അത് ഷെയർ ചെയ്യാൻ വേണ്ടിയിട്ടാണ്. സ്ട്രീമിൽ വരുന്നുണ്ടോ നോക്കാൻ.
ഇതിവിടെ ഓഡിയോ വരുന്നത് ക്ലിയർ ആണോ നോക്കാൻ ഒന്ന് സംസാരിച്ച്.
ഹലോ ഹലോ
ബാക്ക്ഗ്രൗണ്ടൊക്കെ ക്ലിയർ ചെയ്തോ?
അതുകൊണ്ടായിട്ട് അത് ഓഫ് ആവുന്നില്ല. ഇതൊന്ന് എടുത്തോട്ടെ.
എടുക്കല്ലേ ആംഗിൾ പോകും. ഞാൻ സെറ്റിങ്സ് എടുത്ത് തരാം. നിനക്ക് എന്താ പാട്?
സെറ്റിങ്സിൽ
സെർച്ച് ചെയ്യ് ബാക്ക്ഗ്രൗണ്ട്.
ആപ്പ് പെർമിഷൻസ് അതിലാണ്. മാനേജ്മെൻറ്റ്, പെർമിഷൻ മാനേജ്മെൻറ്റ്. വാട്സപ്പിൻ്റെ മാത്രം ബാക്ക്ഗ്രൗണ്ട് ഡാറ്റ ഓഫ് ചെയ്തൊക്കെ അതിലല്ലേ ഇപ്പോൾ വിളിക്കുള്ളൂ. സ്പെഷ്യൽ ആപ്പേഴ്സസ്, ലിസ്റ്റ്, ഇത്രയും അൺഇൻസ്റ്റാൾ ഡാറ്റ യൂസേജ് ഡീറ്റെയിൽസ്,
ഡിസേബിൾ മൊബൈൽ ഡേറ്റ, ഡിസേബിൾ വൈഫൈ. മെസ്സഞ്ചറും കൂടെ ചെയ്തു തരാം. മെസ്സഞ്ചറും കൂടെ ചെയ്തു തരാം. ഔട്ട് എക്സ്റ്റൻഷൻ്റെ
ഞാനൊന്ന് നോക്കിയോളൂ.
ആടാ ഓക്കെ.
ഇത്രയല്ലേ ഉണ്ട്.
അത്രേ ഉള്ളൂ. ഇനി ആരും വിളിക്കാനൊന്നുമില്ല. ക്ലോസ് ചെയ്ത് തരാം. അതെടുത്തു. ഐ വി ക്യാം എടുത്തു. ഐ വി ക്യാം എടുത്തു.
ഓക്കെ സെറ്റ്.
ഒരു മിനിറ്റ് വേണം.
ഓക്കെ
Humanity, and indeed it is a proud moment when our panelists are all here who have done partially their problem solving and product development, and we have one of the best persons who can talk to you about the signal processing and its applications. A person who has done he has been the best, I should say, who can explain to you the complicated things in the most simplest manner. He is the king of digital signal processing, and he has been wonderfully doing a lot of things with signal processing, and currently he is the chair of the Signal Processing Society also of Kerala. He is associate professor at Model Engineering College. He was previously principal of several institutions and a person of vast experience, a real technologist in signal processing. So he will be really able to guide you, especially in the product development side with signal processing. And over to you, Dr. Rajesh MP. Welcome to this Hack for Humanity.
Thank you, Dr. Kijana, Dr. Biju, Sundeep Ma'am and other friends and dear IEEE volunteers. First of all, I am happy to extend my very sincere congratulations to the entire team for the probably breaking the chain, because we were not physically assembling for a long time, around 2 years by now. And this is one of the first IEEE physical event that I am recently attending, other than probably the inauguration of the IEEE Kochi office. That also was a very small crowd. This is somewhat larger crowd. So that is highly appreciated, and it shows that humanity with the advancement in technology can definitely move forward, surpassing all the hurdles on the way. So let us hope that the future will be therefore will be back to the all the normal, or the very good normal, where we could see each other, hug each other, share the spirit of volunteering. That's what is required. We are all missing you in the campuses. Everybody, in one or the other sense, is missing that spirit of humanity, I think. And this has become an opening even for the entire IEEE fraternity in Kerala, that this joint society has come up with this Hack for Humanity. And I understood that almost every project were in that direction on how to improve the quality of life, Anyway, Dr. Biju was just calling me. It looks like a surprise test for me. That is, usually we play with the students, right? If we don't have a stuff to talk, that day we usually conduct a surprise test of some modules, right? So like that, he was just telling me, come and talk on product development or some aspects of signal processing. But I think I'm not that good in that product development aspects, but basically think about sharing certain very basic ideas of digital signal processing, because nowadays, as all of you have a minimum coding skills, either in MATLAB, Python, or some other platforms of the hardware like microcontroller or a special purpose digital signal processor, etc. These things are there. So even the people, because I'm a fan of DSP, basically my research, everything was in signal processing. So wherever I go, I usually talk about signal processing, some of the concepts and misconceptions, because all of you are either electrical, electronics, or computing engineers, generally circuit branch engineers who are sitting here. So I thought I will just again fill me with the back, very old stories only, very basic concept of signal processing, because signal processing, or very specifically digital signal processing, has become little notorious across the campuses. I am telling this everywhere. So it is either in one of the campuses it is called a definite supply paper, some other is a degree stopping paper, people say like that, because of this subject many are not getting the degrees in time, and like that. And when it comes to the digital signal processing, and especially the industrial application side, many are using it, knowingly or unknowingly. You are talking about data science, data analytics, or even when you compute the statistics of a data, financial analysis kind of thing, it is actually DSP. Everything is DSP inspired, in fact. So we are not, extensively or explicitly saying that, okay, what we are doing is digital signal processing. Whenever you just compute the average of a data, it's a digital signal processing application, in fact. So like that, it is everywhere. That is one point. Then, of course, when we think about digital signal processing, there are certain concepts as well as certain misconceptions. Even though we are somewhat good in doing all these things, finally, what I found is, that is probably my practical side of aspect, I think. Many think that it is something problem solving, mathematics. Of course, there is mathematics involved in DSP, that's why it became notorious, I think. But at the same time, if we blend some physical concept with that, definitely it becomes interesting, and you can definitely think about product development or many systems, especially healthcare systems nowadays requires extensive signal processing. You have to monitor a patient, IoT is there, data is there, you have to filter that. Everywhere this DSPs, knowingly or unknowingly, is coming in. Therefore, what I am trying to do today, and whenever you feel it very boring, please tell me, please stop, we can loud it or something like that, no issues. Because it's a friendly DSP discussion, very basics of that, starting from a very small concept. And definitely, if time permits, I will go to what is again very notorious called the Fourier transform. It is, again, notoriously called Fourier transform. Even after BTech and even after MTech, people don't know what it is. E raised to minus j omega cos omega. Very, very long. But I will try to crack it for you. That is the general plan. That's all. Only thing. Only. These are very old stories. Nothing to do with that. But if you know this, of course you can model it, understand it, and you get a physical feeling of what is happening. Therefore, we will start with a very simple question. Why DSP? This is it. Because I was just telling you that we use it everywhere. In IoT, in data analytics, in financial analysis, everywhere signal processing is there. There is a use, statistical signal processing or conventional signal processing, etc. So why signal processing is the question. Why digital signal processing? That is a specific question, not just signal processing. Because anything you do with a diode, a big circuit is a signal processing basically. But why digital signal processing? Have anybody come across such a thing? How many of you are above 6th semester or so? Around 6th and above? Okay, some answers may be there with you. Don't think that this is a surprise examination. So why DSP? The answer is, I think all of you will readily agree that if I state like this, computers are very powerful. Everybody will agree. Even though it's not working for me today, it is very powerful basically. Computers are very powerful. And you know, signal processing is much developed in the electrical engineering side. Starting from capturing a signal, rectifying, amplifying, so many processing you know about signals. So you can alter any of the parameters or some of the parameters together of a signal, like frequency, amplitude, phase. These are the main three parameters. If you alter any of them, it is some kind of signal processing. Amplification, attenuation, and if you altogether vary the frequency, that's called FM, frequency modulation. All these things are signal processing. And the motivation for DSP especially is this thing. Computers are very powerful. But not very simple. It's not like Java, right? It's very powerful. But why can't we make use of this computer for processing signal? That is the only motivation for digital signal processing. Okay, that's good. Appreciate that. Computers are good. So we are using computer for everything. Then for signal processing also. Okay. When we think in that direction, the first hurdle is how we do with it. How can we make use of the computer for signal processing? Thing is, computers can only understand digital language. It will only understand binary zeros and ones, right? So, as such, if you have a signal, you cannot process it. Therefore, to make use of the computer for signal processing, what is essentially required is whatever signal you have should be converted to a digital form. And you know what is it? What is that operation is generally called in electrical engineering? ADC, analog to digital conversion, then store it in the computer, process it. It is possible. Okay, just before going to that, suppose an 8th standard student is approaching you. Because 8th standard, because the physics starts there. Diode, rectifier, things starts over there. I was asking a question because you're all electrical electronics kind of engineers. What is the signal? How will you answer that? So I am not telling you very fantastic kind of things, only basic things, but which can confuse you from time to time. So how do you answer? How do you answer the question? What a signal is? Any opinion? I request every people to say something because Radhagiri means good facility, good room. You must sleep immediately. I don't know how students are surviving here because it's very comfortable, right? Okay. So what is signal? How will you answer as an electrical engineer? Signal, some stories. Please tell me. It may not be full sentences. Something what is coming into your mind on signals. Yes, please make it very loud. Because IEEE means friendly discussion only. Yes, anybody. Just to help me make it interactive and just to see that all of you are listening. Any idea? What is a signal? That's a very usual, very simple kind of a question. Okay. I think. Some stories are coming. What is it? What was the first story? Some information. Okay, stories we will develop later. It's not something like develop a story from forest like that. Okay, information that we know from English second paper, right? Information. It should carry some information. Okay, that's good. Then, it's not clear. It's got some function, mathematical. expression, something like that. Okay, I think he's a dangerous engineer, he likes mathematics. Some function should be there, function of time or something. Mathematics should be there. So don't go to that very dangerous area. Okay, but anyway, just keep it there. Then what? Then what? See, you are answering to 8th standard student. That is the issue. That's why I thought that he is dangerous. Okay, then what? Because this is a very simple question for electrical engineers. You are studying linear and non-linear system analysis to signal processing, control engineering, digital control, everything you are studying, right? And I am asking you very silly questions like the KTU question paper, what is a signal, right? Okay, all these things are there. So many other things could also be attached with that. But I think all of us as electrical and electronics engineers have a natural tendency to, if somebody is asking you the question repeatedly, immediately what you will do is, you will draw a sine wave. That is your way to escape. So this is signal. Don't ask too many questions. This is signal. Okay, time is taken here, amplitude is taken here, maybe voltage in many of the cases. Therefore, this is Vm. This is minus Vm. And of course, it's called peak value, Vm. The other one is negative, is minus Vm. Total is 2 Vm or something like that. Okay, that is okay for the students. But when you start saying RMS value, etc., they will escape. It is again very tough, right? Okay, I'm not going to that. So, anyway, this is a signal. Can you tell me what are the parameters of a signal? We were talking about amplitude. Other than that, what other parameters you can say about this? Characteristics. So when you say about a person, Rajesh, like that, you have some characteristics, right? So like that, what are the parameters or some characteristics that you can attach to this? Amplitude is definitely one. Other than that, time period. Okay, very good. Time period is there. Then what? Frequency. They are related also. 1 by T, very famous. Then what? Phase. These are the major things. But anyway, again, what easy approach is, it is a sine wave. This sine wave is very handsome. Someone like me, right? Very handsome. It has a standard equation. We can very easily explain it. That's why we are drawing a sine wave. If somebody asks you a question, what a signal, you never draw the music signal. Will you draw that? No, it's not possible. It's very complex. Anyway, one attraction of this signal is, this is an analog signal, which could be written as A, cos or sine, 2 pi, ft, even plus theta. This will tell you some of the stories. So the mathematics that he was trying to tell is no ever. What is A in that? Very simple things I am talking about. You may wonder what is happening in IEEE and which is given, right? But some concepts are very essential. What is A? Amplitude. What is the unit? Depends. If it is an electrical signal, it may be current or voltage. If it's a pneumatic signal, if it is some other signal from some other area, that depends. Okay. Amplitude. What is capital F? What is the unit? Hertz. Okay. What is T? Time. So everything is good. But you know, it's not that simple like that. The frequency, I'm giving all of this with the general understanding or assumption that you know, you're good in that. Frequency will be expressed in hertz. Hertz means what? 1 hertz means what? 1? Why very silent? IEEE should know what 1 cycle is, right? What 1 hertz is. 1 cycles per second, fantastic. Only problem is, can you tell me what is the minimum possible value for an analog signal? We are all analog or digital engineers from time to time. So, as electrical engineers, please tell me what is the minimum possible value for this frequency? You know what is frequency? Number of cycles per second, hertz, everything is clear to you. What is the minimum possible value for this F expressed in hertz, and what is the maximum possible value? This is the segment. You are all halfway engineers, that's what I understand, at least for semester, right? What is the unit of units? So we are discussing. Can you tell me the answers? I'm sure they are sitting here, less than 20, but you are going to split over this. Very sure. Can somebody tell me what is the minimum possible value for the frequency of an analog signal, then what is the maximum possible value? Answers, please. Because an immediate answer is not coming up because you are thinking that I am again dangerous kind of fellow. I'll be guiding you somewhere, right? Very. Okay, anyway, what is your answer? Let me see. Let me listen to your answer. Please, make it very fast. So I don't waste much of your time. Just the maximum possible value and minimum possible value for the frequency of a signal. Anybody? Yes. Because we are talking about sampling, ADC, IoT, capturing data. All these are signals with some frequency. You have to convert it, etc., etc. So what is the minimum and maximum possible values for the frequency? Anybody? Make it very fast. So our frequency looks very slow. It is somewhat like DC, I think. We are all. What is the frequency possible? Is it very tough? In hertz, because the unit is in hertz, we know. It is already written. Frequency in hertz is already written. Minimum, maximum values. I want the two ends. Any thought process is coming in? At least you know what it is, isn't it? Number of cycles per second. Anybody? Please. Who was trying to tell something? Let it go wrong, no issues. Why? It's a very simple thing. Frequency of a signal. You see, IEEE means we should be knowing this. What is it? Anybody? Yes? You should have some notions of this, isn't it? Frequency. 0 to infinity. Okay, one answer coming in is 0 to infinity. Okay, one answer. Second answer, not everybody will agree with this, I think. What is the second answer? Second thought process? Somebody has talking about 0 to infinity. 0 to infinity, a short like that. Okay, anything else? So I basically want to see that there is a split in the class. Then only the story becomes interesting. So for that, at least to help me, you project something. Yes, very good. 0 to 1. Very good. Very good. 0 to 1 what? Hertz or what? Kilohertz or megahertz or? Okay, something. Okay. Third answer, anyway. So it is now coming in line with the IEEE bylaws. More than one nomination, voting will be ready. Continuous values. Are you an electrical engineer? Yes, you are a very tough guy. Okay, what is it? Electrical engineer is very clear. Okay, what is it? Please. If it is continuous, I didn't get it. That's why. Please continue. See, this is a very simple 8th standard question. That is the funny side of this. Please, can you please repeat it? No, we are only talking about continuous signal, analog signal. Analog signal. Because I was telling that we are talking about a cycle. That means analog only. We haven't converted it into digital. We will do that. Immediately we do that. We are going for DSP. Any other answers? No. Yes, please. How we write it mathematically? If you think that there is nothing like a limit, what is the other? Infinity to infinity. Minus infinity. Okay, anyway, it's becoming very obvious brand. No, that's what is required. Minus infinity is there. Minus plus infinity. Only positive values. That means 0 to infinity. Okay. 0 to that one question mark is left. So that became an orphan. You are the caretaker, but now you are leaving it somewhere. Okay. Then what? Anybody want to contribute to this? This is a total class. This is good. This is what we require in IT basically. Lot of discussions and no decisions sometimes. Like that, it is progresses. Okay. What do you think about that? And how many support answer? One? At least the proposer is there. Okay. Don't leave them orphan like that. 1, 2, 3, 4, 5. Okay, 6, 7 people are there. He is halfway only, but anyway, we will count it. So 6 or 7 votes. How many are for B? Answer 2? I will add one more answer, I think. Usually we do that, right? None of the above. None of the above is if you don't know something about, engineers use these techniques, non-linearity, they will talk. If you don't know something, we say that okay, it's kind of non-linear system. Don't ask too many questions on that. Electrical engineers will expect to do that. System analysis, their main business. None of the above. Okay, how many are there for second answer? Nobody is there? You are both. Oh, yeah. Okay, so he has a chinna as well, right? Main thing is the okay, something like that. And how many are there for the third answer? None of the above. Because I have written is somebody, okay, professor was explained that I am an ESP guru or something. It's a safer stand, right? It's a very safer stand. That, wow, 2, 3 are there for this. And you know the correct answer is 3. None of the above. So, none of the above is the correct answer. Then what is the correct answer is, you know, if you open signals and system or DSP textbooks, it will be written like this. For an analog signal, the frequency range is from -infinity to +infinity. That is why people hate this. Because nobody will understand what it is. If you open linear system analysis textbook, if you open signals and system textbooks, if you open digital signal processing textbooks, first chapter will be stories, okay, DSP is so and so, like that. Second chapter is signals. They write like this. The frequency range of an analog signal is from -infinity to +infinity. So what it is? That is the question. You know, suppose you talk about 0 hertz. What is the meaning of that? No frequency. Means what? Electrical engineers. Easy. Okay. 1 hertz means what? 1 cycles per second, either sine wave or triangular wave or whatever shape it is. 1 cycle per second. 2 hertz, digestible, we can understand. 2.5 hertz, okay, we can understand. In a second, 2.5 cycles. Anything like positive values, okay for us. Question is, what is -2 hertz? Because they are saying that it is like this. I will tell you one more justification over here. There is no problem mathematically with a mathematician. Okay, you are there. Mathematically, there is no problem in having this f either as a positive quantity or a negative quantity or 0, because you will get a value, you can plot it to either side of the graph or something like that. It is possible. There is no issue mathematically. But physically, what is -2 hertz? 1 hertz is okay for us. Means what? It is finally become a Bharatanatyam, right? We will wave hands like this, but people will be a little confused. What is -2 hertz? Thing is, I will tell you, this is not a correct answer, I think, but usually I say this answer everywhere and escape. Here also I am expecting the same thing. Every electrical engineer sitting here knows that there is a generator at Moolamata and somebody is rotating it and you are getting sine wave. Am I right? Great. At home you receive. Suppose somebody is rotating with the same generator in the other direction, the same speed. What happens? Signal will be produced. It will dissipate the same power on and on, isn't it? If you treat this as positive frequency, this is negative frequency, no more questions. Please be satisfied with that. That's the explanation. And if you are asking so many questions, it is an assignment. Okay. So this means mathematically the frequency can be from -infinity to +infinity. It doesn't mean that physically it is like that. Physical frequencies may only vary from 0 to infinity. 0 means DC and whatever higher values of it. But theoretically, mathematically, it is minus infinity to plus infinity. And of course, these notions can be used to satisfy ourselves that there will be frequency in this thing. Okay, this is the story of the analog signal. And with this background with us, we can definitely move to digital signal processing. We will now think about DSP. Now we are generally assuming that we are all good in analog signal processing. We know the signal, we know the amplitude, we know the phase, we know the, what I should say, frequency range, everything we know now. Okay, very good. Now we think about what I call digital signal processing. It's a Herman jumping. So many things are there in between, but anyway, we are moving to digital signal processing. Thing is, we need to convert an analog signal to digital signal. That is what is required. And that process is called ADC, analog to digital conversion. And circuits are there called analog to digital conversion circuit. Everything you know, some of these things you have heard somewhere. How we do that? That is the question. How we do that? Very good. The word sampling comes in. What is that? Suppose you have a very useful signal like this. Is it sine wave? No, it's actually music by Yeshudas. Suppose recorded signal, music, and I want to convert this into digital because I cannot process this in computer as such. As a continuous signal, I cannot store it because computer can only understand the values of binary. So you have to convert the samples and that binary value should be stored in the computer, etc. How we do that? Sampling. And what do you mean by sampling? How you do that? In words. Storytelling is very easy, isn't it? In many of the papers you write a lot of things. But KTU is providing only one booklet, I think. Therefore, the stories became very shorter nowadays. So how we convert this, how the sampling process progresses, how we do that? This is it. I am not wasting time. This is what is happening. TS. Thing is, at regular intervals, we will look into the magnitude of the signal. And this magnitude, say, called V0, this magnitude, say, V1, this magnitude, say, is V2 voltage. Okay, music by thing is, we look into the magnitude and we will understand that, okay, this is 2.879386 volt. Something like that. What we do, the corresponding binary value for that 2.87, that value, because we want exact, very good precision, quality, etc. Because we are processing HLRs after converting into digital and processing, and when it comes out, it would have good quality, right? Therefore, we are not ready for any compromises, values, etc. Therefore, as such, this 2.879386, whatever it is, should be converted into binary and stored in the computer. From that point onwards, problem starts. This is what you have to understand. That's why I am telling that this signal processing is important. So, can you tell me what is the binary equivalent of this number or value? 2 point something. Can you get me that? And that is actually called the first sample x0. That is the name given to them. The other notation is x0. So, what's the binary value? Can somebody tell me? Your calculator can be used. You are all equipped with smart devices, isn't it? Smartphones are there. Okay. Probably other than all of us, everything around us is very smart nowadays, including the classroom. This is called a smart classroom, right? Okay, what is it? The binary equivalent. Again, very simple. People hate digital signal processing, but people like digital electronics because everybody will get a pass mark. At least because of these number conversions. Convert the following numbers into binary, etc. And nowadays, because of KTU, you need to answer only for 70 marks, I think. So it's very easy. Okay, what is the binary equivalent of this number? Thing is, what is the binary equivalent of this part? 1 0. And the remaining is going to be a trouble for us. That's what I'm trying to tell you. Sometimes it will be infinitely long. If you remember that process, it is you have to multiply by 2 and like that you go. Until you get a 1 there and remaining 0. Sometimes what happens is we may require infinite number of things to store this data in the computer. That is the first challenge. Can we do that? No. Because our memory size, our register size, etc. are very limited in length. For example, we are talking about 8-bit computer, 16-bit computer, 32-bit, 128-bit, etc. Nothing like infinite bit. Anyway, the possible number of bits is actually called word length of the processor or the computer. What? Word length. So you can store only that much. So what we will do? How we, then only possibilities. There is nothing like an infinite word length kind of a register or memory or computer. It's an utopian computer then. So the possibility is, okay, we have an n-bit computer. Then the only, approach is rounding or truncation. Rounding or truncation. Suppose you can store only 1, 2, 3, 4. Cut and remove. No way. Because we don't have any other approaches. It's called truncation. Or you round it to some value and store it there. So if you have given 120 rupees to your friend and finally if he is only returning 100, it's okay, right? At least 100 is there. Like that we can round and finish it off. But either way, with the truncation or rounding, we will commit a mistake. An error in the amplitude value. Am I right? Error in the amplitude value. How can we minimize the damage of that error is? We can either use computers with largest word like available, may not be available every time. And another possibility is you take more samples so that the next time the reconstruction will be somewhat perfect. Reconstruction will be somewhat perfect. It is somewhat like a curve fitting, that the digital to analog conversion. So if you take more samples, then sometimes you can reduce the attack. Damage due to this error in amplitude. But there is a problem with that. Then you require more amount of memory locations. You are storing more value means more memory is required. So always there is a trade-off between memory availability, word length, this error, etc. Anyway, all together, all these arrays connected together in this journey to analog, in this journey of analog to digital is generally called quantization errors. They are called quantization errors. Some people call it ADC error, analog to digital conversion error, etc. etc. It is called. Anyway, whenever we move from analog to digital, first time issue is this amplitude issue. We cannot have a complete solution for that, but we can try to reduce the problem of that effect of that error by using more samples stored in the computer or using the computer with the maximum word length available. This is one issue. Next issue is, it is somewhat complex. I will tell you what is the next issue. So you again see that, and okay, in words it is like this, but actually some circuitry will do this. That is called the analog to digital converter. I am not going into that theories now. But now I am trying to introduce to you another issue which we face when we move from analog to digital. XPT. XC. Thing is, what is A? H loss. Basic by H loss. And we are sampling. And now you can see two other signals I have shown there. question therefore is, except the data set stored in the computer, whether it is representing A, B or C in the analog. That is the question. Can you answer this question? Otherwise I will go the APU style, or we can try to answer this question on how we solve this problem. If you electronically say some technique to solve this problem, either you face it or you escape. These are the choices. Can you please think about that? Whether the problem is clear to you? Yes, they are not correlated, they don't have any relationship with each other, but they possess the same magnitude at the instance of sampling. That's the only thing. And we are sampling and storing it in the computer. Except, the data is called except. Whether that except represents A, B or C of the analog signals. The analog. Can you please discuss that? I think simply talking to each other may help you from sleeping. And probably you can think about some DSP as well. So try to talk and use your knowledge in signal processing. Try to say something on this. I think at least the problem is clear. Solution may not be clear because hackathon means solutions will arise very slowly, right? We propose this and that, and finally somebody will tell us it's not practical. So we change it. Hackathon means like that. Okay, so what's it? Finally. Whether Xn stored in the computer is representing A, B or C. Answer that. Otherwise tell me some techniques by which you can solve this problem or rectify this problem. Anything is okay. It carries equal marks. Anybody? Whether at least are you convinced that there is a problem like this? Yes. Okay. That's good. And tell me when I have to stop. Okay, Biju, tell me please. Remind me on the time. Because teachers have a very dangerous behavior. They will keep on talking even if listeners are sleeping. Because they think that it is their natural responsibility to speak continuously. Because online means no guarantee that the guys are there. You put the chair in between, lock in and escape. Okay. Okay, please try to tell me some opinion on this.
You have time up to 5:30.
Okay. It's possible. Some DSP within 5:30. Okay, what is it? What's your answer? Yes, filtering, isn't it? It's a very dangerous topic, you know. If you use some filtering, you will filter out B and C and only A will come, right? Okay, that's a good suggestion. That's a good suggestion. But again, okay, filter is you are suggesting for a solution, right? You are suggesting a solution, but not answering my first question, isn't it? Whether Xn is representing A, B or C is not answered, but rather avoid the problem using filter was the answer. So you are answering B. Anything else from anybody else? Yes, this is a critical problem. Sometimes teachers miss this in the class to tell you that such a problem is there in, digital signal processing. When you go from, this should be resolved, otherwise we cannot do DSP. We cannot believe it. A will be misinterpreted as B and B will be misinterpreted as C or something like that will happen. Anyway, I can tell you, I am not wasting your time. This problem that a data set like Xn is equal to X0, X1, X2, these are all values stored in the computer. That's it. It's an array or a vector, we could say. It's a one-dimensional, it's not an array, it's a one-dimensional data. So a data stored in the computer can theoretically represent infinite number of signals in the analog domain. Like A, B, C, anybody can draw any number of signals like that, isn't it? And this problem is called the aliasing problem. That's the physical meaning of aliasing problem. In many contexts, you are talking about aliasing problem. People use this word. You may see that, okay, whether alias was discovered, this is a confusing topic, very electrical engineers. Have you heard about aliasing problem? Yes or no? Yes. What is it? It is the fact that a data stored in the computer can basically represent infinite number of signals in the continuous network. And there is a fundamental question, what DSP is possible then, isn't it? It's not possible. It's not good. But anyway, I will put you a numerical example here. Suppose you have a signal with a frequency 100 hertz. You are interested to process this. Suppose this is your H-das. Fs equal to 100 hertz. We want to process it, etc. Can you suggest a sampling frequency for this? You know that any signal should be sampled at 2 times this frequency. At least 200 is required. Let us choose 300. No issues. Okay, this is FA, analog signal of 100 hertz. Then Fs is the sampling frequency. Okay, we write capital X. Fa 100 hertz. Fs is equal to 300 hertz. Is it okay for you? Yes, it's okay for you. Because at least 200 is equal to choosing 300. No issues. When you choose 300, you are taking more samples. You require more memory. Please remember that. Whenever you increase the sampling period, that's very good. Perfection will be there in reconstruction, etc. But you require more memory. But anyway, it's okay. 300 hertz. If that is the case, suppose there are frequencies called Fk equal to Fa plus Kfs, where K is equal to 1, 2, 3, etc. Is the situation. For example, F1 is equal to Fa 100 plus K is 1. That's why Fa 1 into Fs 300 equal to 400 hertz. These are all hertz. F2 will be another frequency, Fa plus 2 into Fs equal to simply 700 hertz. My point is, this is an assignment. You have to go home, draw this either in computer or a graph sheet. You take a graph sheet, draw a 100 hertz signal, sample it at 300. That means you write, draw vertical lines at 1 by 300 hertz time period, sampling. Draw another signal with same magnitude but frequency equal to 400. Third signal with same magnitude but frequency equal to 700. You will see that all the frequencies like 400, 700, etc. will have the same magnitude at the instance of sampling. Otherwise, they are different because they are different frequencies. Therefore, this 100 hertz signal, which we are interested in, is called the fundamental frequency. And all other frequencies like 400, 700, etc. are called alias frequencies of this 100 hertz at the sampling rate of 300 hertz. At the sampling rate of 300 hertz. If the sampling rate is different, the alias frequencies will also be different. What is alias frequency? Alias frequency is a fancy dress. They will look like the original frequency, the fundamental frequency, 100 hertz, at the instance of sampling. So, his suggestion is good. Fortunately, one observation possible is all the alias frequencies are larger compared to the fundamental frequency. What is the fundamental frequency of interest? 100 hertz. But the 400, which is the first disturbance, the 700, the second disturbance, they are anyway minimally the fundamental frequency plus the sampling frequency. So they are much away from that. Therefore, before the analog to digital converter, ADC, you have a filter. Say in this particular case, a low pass filter with 100 hertz cutoff frequency. That means what? Only the 100 hertz and below will be passed. All others will be physically blocked. Then the ADC is very safe. Only HDAS will come in. All others will be physically blocked. The security agent is the filter. And remember, every time this filter, okay, this is the input signal. If unknowingly the VC, etc. are coming, they will be blocked. And only the required signal will be coming in and ADC, then digital equivalent will be produced. Therefore, this filter is actually called anti-alias filter. Anti-alias filter, it is always a low-pass filter. Anti-alias filter will be always a low-pass filter because the alias frequencies are larger than the fundamental frequency by an amount at least of a sampling frequency or the multiples of that. Okay, so this is how the journey from analog to digital is very tough. That's what I was trying to tell you. So with this, now we will land up in the digital domain. So a continuous signal will be converted into a set of numbers. And DSP means we will be only dealing with these arrays. Xn is equal to, that is basically a matrix, right? A vector or a matrix. So like that, every operation that you do in the continuous time domain can be done with these set of numbers stored in the computer. amplification, filtering, everything can be done. And that is called a digital signal processing. So how exactly we do that? Etc. different from our approach. But anyway, this is the journey, first step from analog to digital domain. Any questions at this point? We were talking about analog signal, the concept of frequency, then the ADC, then this aliasing issue. Like that, we landed somewhat comfortably that okay, signal processing is somewhat possible. We can store the signal in a computer and how to process it coming up only. Any questions or opinions at this point of time? Because you also have some notions on signals, ADC, other kind of things in your mind because of your learning process. Anything you want to add, anything you want to ask? The journey is little, tough from analog to digital. First one was an amplitude issue. Now it is a frequency issue. This is a frequency issue. The first one, the quantization error was that word length thing was an amplitude issue. This is a frequency issue. One more issue is there. You know, any signal should be sampled at twice its frequency. That is sampling theorem. That means the analog to digital converter should work in that speed. That actually, in a reverse manner, indicate the speed of conversion, isn't it? You know, nowadays, with the currently available technologies, no ADC can work beyond some 20 megahertz. So DSP is basically possible up to around 10 megahertz. Beyond 10 megahertz, DSP is mission impossible as of now. But when the ADC technologies improves, you may be able to do that. These are the three limitations by which we are moving from analog to digital. One is the amplitude issue, quantization error, etc. Second, that finite word electrical. Second one, this aliasing issue, frequency related issue. Third one, practical issue related to speed of conversion. So with these limitations, actually we are moving to digital domain. But again, the DSP is very smart, as we usually say. Okay, I think if I continue the story, it will be a burden for you. Because you were all working and thinking and writing, submitting, presenting. We will continue this journey, we will continue this discussion. IEEE is definitely a very good platform. We will definitely continue discussion. If you want more on this, we will arrange either online or otherwise we will try to assemble and discuss it. Please see that something good is there inside DSP. If you understand it physically also, aliasing a lot of equations are there. ADC a lot of equations are there. ADC error, a lot of equations are there, but see what is actually happening. Physical sense you add to what you learn will help you. So that is my only conclusion. It was just a chat. DSP chat is very to kill your time from some 4 to 5:30, that's all. But I think I just conveyed some very basic things to you. Thank you, Professor Biju and other organizers for giving me a chance to interact with the IEEE volunteers. If you have a specific question, we will try to answer it, otherwise we will close. And don't see that it is the end of the story, we are just beginning of it. We will continue, definitely.
So we have a couple of minutes, queries you can ask.
Generally on DSP, even if I haven't told, I can tell you which of the theories at DSP. If you have a general something in your mind, that also can be asked. Just now. Yes. Okay, that's a very good question. Especially the COVID, post-COVID situation. Anything, okay, we can, whenever we think about DSP, people think that it is highly theoretical, mathematical, we may not be able to do something on that. But if you think about some biomedical applications, especially patient monitoring kind of thing, because untouchability has come back to Kerala everywhere in the world, right, because of COVID. So how remotely and without touching, how we monitor systems, including patients, has become very important. So such thought process is coming up. And everywhere when we think about safety, measurement, temperature measurement, everywhere sensors are in. IoT is generally called. So whatever IoT, signal processing is there. Many of the things that we are black box engineers, we purchase this thing, that is the ADC system, connected, you will get the digital. But sometimes we may not be able to go and exactly correct it. You know what is actually happening inside. So don't never believe in black box engineering. Rather try to see what is the theory of that conversion, how it is doing. Otherwise you fire your own circuit, etc. Anyway, medical field is one thing. And definitely data analytics is full of DSP. Statistical signal processing it is. Okay, that may be a computer-based purely software development kind of a project. But if it is something very good like predicting the corona or something, because in prediction and kind of modeling is another area. You try to develop models for physiological system, etc., and try to predict the possibility of either a sick condition or something, financial data or something like that. These kinds of modeling, prediction, biomedical engineering, etc., are some of the possibilities. That's a general answer, possible.
Sir, these students may be planning to use DSP for their projects.
Yeah. Okay, sir.
So, do you have any few tips for students to how
Okay.
to select DSP?
Two approaches are possible. That's a good question. Thank you, Professor Biju. One thing is, it can be a completely software-based assignment. DSP. In MATLAB you can do it, Python you can do it, or in whatever, even C you can do DSP, algorithms, etc. But other track is using embedded system. Special purpose digital signals processors are available. So you have to sometimes assembly coding, etc. And microcontroller programming, so many tools are available. Key and other things, somewhat. That way also you can think about DSP project. That will give you a better feeling. MATLAB problem is, many people, I have seen that we have done FFT. FFT means what? Fast Fourier transform. You feed something, you get some output. We don't know what it is. Simply plotting, everything is there. In MATLAB, it's a fantastic tool. You can plot any nonsense. And you can fool people also. These are the results we got. That way it is happening. Again, the black box modeling is happening. We don't know what is exactly inside. So, I request, especially if it is a mini project, you like to go to the embedded side of DSP, embedded DSP, real IoT, sense it, converted, etc. But after learning that, you will get a theoretical background. If you are theoretically strong, then you can either go for Python, MATLAB, etc. because you know what is happening there. Otherwise, the thing is, any data is available in the internet, any program is available in the internet, but the thing is that we should be thorough with that. You use any program, no issues, but you know what it is. You should be able to correct the alpha beta going there only if you know the theory. Okay, please understand it. If you are a minor project, go for embedded DSP. Then, if you are strong in that, then go for software development. It doesn't matter because you know the theory. But if you know Fourier transform, you know ADC, you know ADSC, then you can do it. No problem. So that's my general suggestion. Again.
Sir, according to most of the students, DSP is a very tough subject.
Yeah.
So, what approach should we take to make it easy? What approach should we take?
My point is, whenever I try to teach DSP, I would like to put physical sensors to that. Otherwise, it is very complex. Isn't it? E raised to minus j omega. What is e raised to minus j omega? Nobody knows. So, if you are only playing with that, some teachers will also doing taking some wrong approach in that DSP. It finally becomes a headache and problem solving. So, you see that you are able to attach some physical meaning to everything that you are doing. All these have meaning in fact. Aliasing has this meaning. We see now. We saw now. So like that, if you are not adding in the physical concept, it won't make a sense for you. You may pass the examination because it's a separate art. Writing and getting a pass mark in the examination is a separate art. That doesn't guarantee you that you know DSP or any other is like that, but especially, so try to see physical sense. Okay, I don't know how you get it. If somebody is not helping you, sometimes you won't get that. Some good storyteller should be there in every college on DSP. Otherwise, that is why people hate this because they feel that it's highly mathematical, like even worse than the control system theories. So you should try to understand it, the physical meaning, then attach mathematics, then it will be easy.
Students can use MATLAB also to learn.
MATLAB will give you a feeling on what is exactly happening. I have taken for SCT, Trivandrum, 3 days, only Fourier transform. 3 days, Fourier transform. Like that, if you extensively sit and think, Fourier transform is basically very simple. If you know a little bit of computer coding, it's going to be very amazing. You will clearly understand what it is. Okay, sometimes I think we will talk about that. So like that, make use of MATLAB, because for every operation there is a command available in MATLAB. And if you see a plot of what you are reading in the textbook, as Dr. Biju is trying to point out, then you will get a better understanding. Okay, this is it. I was drawing like this. This is clear to you, right? Like that, even if it is very simple of plotting a sine wave, two sine waves and seeing the phase difference, plot it in MATLAB. Or some other platform of your choice. That is a better practice. You start from very small things of plotting the signals to complex things like Fourier transform. In many of our DSP laboratories, what unfortunately happening is, everybody will from beginning to end will do different experiments. Experiment number 1, plotting sine wave. Experiment number 2, plotting triangular wave. One command only, right? Experiment number 3, pulse. Plotting a pulse. And a procedure. Open MATLAB, write the command, we got the output. Not waste time. This is because people turn silly at times, right? Okay. I try to see that being IEEE guys, some of us could sit at times to discuss. If it feel like okay, it's better to listen from another person, along with your professor, it's good. That's only way. But that's one, positive side of networking like IEEE. Anyway, any good thing or bad thing should have an end. We will try to wind up here because you all want to reach home also. Many of you, right? Thank you, Dr. Vijana and Dr. Biju and all IEEE volunteers. I'm happy to see that you have hosted this event in the territory of Kochi subsection without our permissions. Very good. Welcome to Kochi once again. Come and visit and host more events in Kochi. We are all ready to help you.
We have a new facility at Kochi also.
Okay, in IEEE we will now argue for some territorial rights or something like that. Okay. Thank you very much.
So thank you, Rajesh sir, for giving us a very beautiful insight on the fundamentals of DSP, and I'm sure that all our participants got some real interest in learning DSP, especially you are on to the third year and you are about to start studying DSP. So thank you, Rajesh sir, once again. And I request Vijana madam to hand over a small memento to Rajesh sir as a token of our respect and gratitude.
So we were missing this part. I have received
any
number of lectures. Thank you for those. The last 2 years, my computer is filled with
This is something that physical.
Thank you.
So first time we will suspect you. This is also mutual. Okay, thank you once again, and we shall go on to that hall for the delegates to start. So you have 1 more hour, right, before our cultural programming. So you can work up to 6:30, and we have arranged a very good cultural evening with cultural programs both from our delegates and volunteers. After that, we will have the gala dinner. Okay, thank you.
That is the industry part.
Yeah, most interesting.